Hello students, so welcome to 60 out of 60 in KCET Chemistry 2025 series in just 200 days. So as you all know, we have started, we have completed the PU2 complete syllabus, and now we are going to do the PYQs, right? We have started the PYQ series. So today we'll be discussing the last 10 years and top 30 previous year questions from the chapter coordination compounds. Okay, so from 2015 to 2024, the most repeated, most important top 30 questions we have collected. Okay, so now let us see, and one more request, please join our WhatsApp channel. The link of the WhatsApp channel will be there in the description section of this video, so you can go there and join the WhatsApp channel so that you can get access to all these PDF notes, our mock test, our solutions. Everything is available in the WhatsApp channel, so please do not forget to join the channel. Okay, now coming to the questions here. So this chapter, basically you can expect like 3 to 4 questions you can easily expect from this chapter. Okay, so let us see the first question here. Okay, so the complex hexaamine platinum 4 chloride will give dash number of ions on ionization. So now if you see here, this question was asked in 2022 and it is a super easy question if you just know how to write the complex structure and you know the concept of primary valency and secondary valency. Okay, Werner's theory concept. So first of all, if I write hexaamine platinum 4, right? So I have hexaamine platinum 4 and chloride. Right, now the point here is to write the formula correctly. You see the charge of this is plus 4, right? So that means what? This platinum charge is 4, this charge is 0, so that means the complex charge is plus 4 and chloride is minus 1. So if it we do crisscross, then I'll get the formula of the complex like this. Right, now if it ionizes, this part will give you 1 ion and here 4 chlorines will be produced. So the total number of ions produced will be 5. So the correct answer here is option number C. Okay, next question. Addition of excess AgNO3 to an aqueous solution of 1 mole PdCl2.4NH3 give 2 moles of AgCl. The conductivity of this solution corresponds to. So now this question was asked in 2019. It is also easy to moderate question if you know what is how to find out the electrolyte type. Okay, so first of all we will see what is the formula of the compound. So now if you see, we have this compound is present and we add excess of AgNO3, only 2 moles of AgCl is produced. Okay, so what you can imagine like this, we have this compound, okay, that is PdCl2.4NH3. okay, this compound is already present. Okay, now what you have done, you have added extra AgNO3. Okay, now if you add extra AgNO3, this will give you precipitate, it gave you 2 moles of AgCl. Okay, now what is that mean? That in this compound only 2 chlorines are present outside. So I can write the formula like this, PdNH3,4Cl2. Okay, now if this is there, then 2 chlorine ions will be produced, and when you add excess of AgNO3, only 2 moles of AgCl will be produced. Now if you see the type of electrolyte here, okay, so what will be the charge of this one? We will have like, this will give you 1 ion and this will give you another ion, right? 2 chlorine ions will get and 1 cation and 2 anion will get. So this is a 1,2 electrolyte. So correct answer here is option number C. Okay, now let us see the next question. So now if you see, how many ions per molecule are produced in a solution when more salt is dissolved in excess of water? So this question was asked in the year 2015. Okay, and this is a moderate level question because more salt formula many of you do not remember. Okay, if you know the formula of more salt, then it is a very easy question. So let us see what is the formula of more salt. So we have so more salt formula is NH4 whole 2. Okay, so we don't need square bracket here. NH4 whole 2 FeSO4 whole 2 dot 6H2O. Okay, so now if you ionize it, we'll get 2 ammonium ions, 1 Fe ion and 2 sulfate ion. So the total number of ions produced will be 5. Okay, so correct answer will be option number A here. Okay, next question, topic is important definitions. So in your NCERT book there is a topic important definitions, and many concepts have been discussed there, so you must be knowing them very well. Okay, so now if you see homoleptic complexes among the following are. So this question was asked in 2021. It is super easy question if you know what is the definition of homoleptic. So what is homoleptic? Homoleptic complexes, so if I write here homoleptic, okay, and there is another term that is heteroleptic. Okay, now what is homoleptic? Homoleptic means all ligands are same. Okay, and what is heteroleptic? Different ligands are there. There are different ligands. Okay, so now if you see here, we can see that here only C2O4 is the only ligand that is present. Okay, here you can see chlorine is also present, En is also present. So here types of ligand is 2, here types of ligand is 1, only one type, and here also we have only one type of ligand. So which are your homoleptic? 1 and 3. So the correct answer here will be option number C. Okay, fine. Next question, the coordination number of Fe and cobalt in the complex ions. So we have been given with 2 complex and you need to find their coordination number. Okay, again this is definition, from there you need to find out. So this question was asked in 2020. It will be a super easy question, provided you should know about denticity. If you do not know about denticity, you might make a mistake here. Okay, so now you see what is coordination number. How can I explain coordination number? It is the number of bonds. I can say number of bonds formed between the metal and ligand. Okay, how many bonds are there between the metal and the ligand? Okay, so now if you see here, cobalt, SCN4 is there. So each SCN forms one bond with cobalt. Okay, each SCN forms one bond with cobalt. So if there are 4 SCN, then 4 bonds will form. So definitely I can say the coordination number of cobalt here is 4. Okay, so we can eliminate these 2 options. Okay, now coming to this one, here is what students can make mistake if they do not know about denticity. Now each C2O4, remember each C2O4 forms 2 bonds. Okay, forms 2 bonds with the metal. That is why in the definition I did not write number of ligands present, because ligands can be less but they can form more bonds. So each C2O4 forms 2 bonds with the metal. Then if there are 3 C2O4, then how many bonds will form? Each one is forming 2. 3 C2O4 will form 6 bonds. So Fe is having how many bonds with the ligand here? 6 bonds. So coordination number will be 6. So we can eliminate this option also. Correct answer will be option number C here. Okay. So now let us see the next question here. Which among the following is the strongest ligand? Okay, so this is also very easy question, provided you have remembered the order of the ligands. Okay, strength of the ligands, that is the spectrochemical series. So you must remember the spectrochemical series. Okay, so here if you know CO is the strongest ligand, so correct answer is option number C. Okay. Next question, the coordination number and the oxidation state of the element M in the complex, this complex is given to you, are respectively. So what you need to find? The oxidation state and the coordination number. Okay, so this is also 2017 question, easy question if you know about definitions and density, and you should know how to calculate the oxidation number. So now if we see here that we have the first, we need to find the coordination number. Okay, so like as I told you, each C2O4, okay, and En forms 2 bonds with metal, forms 2 bonds with metal. Okay, each C2O4 and En forms 2 bond with metal. Now if you see here, we have one C2O4, so that will form 2 bonds, and here we have 2 En. So one En is forming 2 bonds, so 2 En will form 4 bonds. So total 4 bonds here and 2 bonds here, that is 6. So the coordination number is 6. So we can eliminate these two options. Okay, coordination number is 6, so any one of this answer can be the correct answer. Now let us calculate the oxidation state. Let the oxidation state of manganese M be X. We need to find for metal. En is a neutral ligand, so its charge is 0. C2O4 is a charge is -2, and we have NO2 as -1. Okay, so now if I solve this, okay, so we will get as 3, right? So the charge here is 3, so this also not the correct answer. Correct answer is option number C. Okay, that is 6 and 3. Clear? Now let us go to the next question. Number of stereoisomers exhibited by COEN whole to Cl2. So we have come to the topic of isomers 2020 question. This is also easy question, so provided you should be knowing about denticity and about optical isomers. Okay, so now if I see COEN whole to Cl2, so now CO, first I can draw one structure like this. Okay, this is COEN whole to Cl2, this is the trans form, right? Now this is one isomer. Now it can also have a cis form, right? So if I draw the cis one, it will be like this. We have, okay, this is the form. Now what happens here, this one is a cis form. Okay, now this mirror image of this one will also be an optically active compound, so I can have like this Cl, Cl, we have En here and we have En here. Okay, so now what happens, these two are optical isomers and this is one geometrical isomer, so total number of stereoisomers we can have is 3, so the correct answer here will be option number C. Now generally students write 2 because they remember cis and trans, but you should remember cis form also has a mirror image which is also optically active. Okay, fine. Next question. FeNO2Cl3 and FeONO3Cl3 shows. So this question was asked in 2018. So structural isomerism question, very easy question. So if you remember, this type of ligands are there. What is this type of ligands? Ambidentate ligands, right? Ambidentate ligands. If ambidentate ligands are present, then we will always have linkage isomerism. So correct answer is option number A. Now what is ambidentate ligands? Ambidentate ligands means those ligands which can form, which has 2 donor atoms, okay, but only one binds at one time. Okay, now for example, if you see here N, right, N is forming bond here, but O also has a donor atom. O can also form bond, but at one time we have only N here. When O is forming bond, N is not forming bond, and when N is involved in bond formation, O is not taking part in bond formation, right? There are many examples like this. First one is this NO2 and ONO, then you have SCN and NCS, then you have CN and NC. Any of these ligands, if you find, they form always linkage isomerism. Okay, option number A. Next question. Square planar complex of the type MAXBL, where A, B, X and L are unidentate ligands, shows following set of isomerism. So now if you see, we have like this. So this is also, I can say, little easy to moderate question. If you have studied isomerism, then very simple question. It was asked in 2017. Okay, we have M square planar complex, right? So you have like this A, X, B and L. Okay, so that means we need to think that any one of these three, okay, like 3 will be of one type and another will be of different type. So A and B I have kept trans here, right? That is possible. Next we can have like so this is one trans geometry, that is possible. Next, what we can do, we can have like X and B as trans, okay, and right, this is one possible. And then we have like this also we can draw. L is there and one more X, right? So what I'm saying here is, see, AX is cis here, okay, again AX is cis here, so we got two cis type of this and we got one trans type of this. So we will get two cis and one trans type, so that is option number A, okay, fine. Next we can see next question. The number of stereoisomers possible for the octahedral complex is, okay, the number of isomers possible for the octahedral complex of the type COCl2EnNH3 2. Okay, so this is 2016 question. Again, this is a moderate level question as well, because you should remember all the isomers that is possible. So let us see. First of all, I can do like this: COCl2 on one side, okay, NH3 on one side, okay, and then I have a En here, okay. Now if you see this particular complex, okay, whether it is optically active or not, if you want to find, you need to search for plane of symmetry. If there is any plane which is cutting the molecule exactly into two half, okay, then you can easily say that this is optically inactive. So now if I see in this particular molecule, if I break the molecule in this part, then the upper half and the lower half is exactly same, right? So this is a molecule, or this is a compound which doesn't have any optical isomer. So this is one geometry, okay. Next, what I can do, similar to this, I'll draw like this. Now I'll take NH3 on the trans, okay, and I have Cl here, and then En, right? The same thing is here also, plane of symmetry is there. So this is one geometry, this is second geometry. We got two isomers till now. Now if you see another one where I'll keep this NH3 and Cl in cis position like this, NH3, okay, Cl and En. Okay, now if you see, we cannot have any plane of symmetry here. No molecule, no plane is there which is cutting the molecule exactly into two half. So that means this is optically active. Okay, optically active. If this is optically active, then it will have a enantiomer also. Its mirror image will also be there. So we will have like this: En, NH3, here NH3, and Cl and Cl. Right. So now if you see, these are two isomers which are optically active, these are two isomers which are optically inactive. So the total number of isomers is 4, and the correct answer is option number D here. Okay. Next, question number 12. Which of the following will be able to show geometrical isomerism? So question was asked in 2015. This is a super easy question. So tetrahedrals do not show geometrical isomerism, so we can eliminate them. Square planar can show, but it should not be of this type, MA3B, that is also not there. MABCD, that can show, so correct answer is option number D here. Next, so next topic is your nomenclature, so we'll go for this one. So this question is, which formula and name combination is incorrect? Okay, so recent question, last year this question was asked in 2023. So this is also nomenclature easy question if you remember all the rules of nomenclature. So now I'll be telling you, like, see, first one, potassium is there. First you should name the cation, that is correct. Now we are going to name the complex. So first we will name the ligands. So 3 ligands are there, so trioxalato, and since aluminium is part of the negative ion, so its name will end with ATE. So aluminate 3. Okay. So this statement or this name correct is correct. We need to find the incorrect one. Let us see the next one. Here we should only complex is there. We should name the ligands alphabetically. So I have first diamine, that is correct. Next chlorido, okay. Then nitrito and platinum 2. This is also correct. Okay. Next one, if we see here, so first this cation has to be named and the name of the ligand should be taken first. So we have first dichlorido, okay, then fine. Then we have ethane diethylene diamine. Here if you should remember, for using, for giving a number for these type of ligands, we use the word base tris, right, tetris. Okay, so these type of words are used, not bi, di, tri. So that is why this one is incorrect. So correct answer here will be option number C. Okay. Next question, the correct IUPAC name of cisplatin is. So if you remember, we have in cisplatin, first of all, diamine dichlorido platinum 0. So in di we have like this cisplatin, right? So PT, we have NH3 and we have Cl, right? So that means the platinum charge here must be +2. So we can eliminate all these options. So that is why the correct answer will be option number C. This question was asked in 2022 and it was a super easy question. Now coming to question number 15, the IUPAC name of the given compound, 2021 question. Again, nomenclature, very easy question, followed by rules are everything known to you perfectly. So now if you see here, first we will name the ligands. This name ligand is amine and this is carbonato. First is amine, right? So we have pentaamine. So pentaamine and pentaamine. We can, here also we have pentaamine. We can eliminate this option. Next, after that we have carbonato. So here also carbonato is present. Here also we have carbonato and here there is no carbonato, so we can eliminate this option. Next we have cobalt. So here cobalt is there, here also cobalt is there. So we need to calculate the charge properly. Okay. So if you see cobalt is X, this is 0. Okay. Carbonate is -2 and that is -1. So X is equal to +3, right? So you should check the charge of cobalt. So here also it is +3 and here also it is +3. Okay. Next we have cobalt is in the cation part. Right, so name should be ending with only name. There should not be any ATE or suffix should not be there. So here you can see cobaltate is given. So that is why this is also incorrect. So correct answer will be option number A here. Okay. Let us see the next question here. So give the IUPAC name of this compound. Okay, so this question was asked in 2020. Again, this is a very easy question. Nomenclature basic rules if you know. So you see one complex, like one is your cation, another is an anion. So one first thing you should think that this one will end with platinum and this one will end with platinate, right? Because it is an anion complex. So we should have platinate here. Okay, so you can see that here first is platinate, so we can eliminate this option. Here also first platinate, so we can eliminate this option. Here there is platinate and here both are platinum, so we can eliminate this option also. Correct answer will definitely be option number C. But now let us check the answer. So we have here 4 amine groups, so I have tetraamine. Okay, platinum 2. Now one more thing that you should keep in mind, that there is no charges or no subscript, subscripts are here. That happens when both the cation and anionic charges are same. Okay, so now if you see here both platinum are in +2 state, so like this is +2 and this is -2, so it get cancelled, right? So that is also one thing that you need to keep in mind. Next we have tetrachloridoplatinate, so correct answer is option number C. Okay, fine. Next question, the formula of penta-aqua-nitrato chromium 3 nitrate is. Okay, this question was asked in 2019. This is also very easy question, provided you know the basic rules and you know how to calculate the oxidation number, do the crisscross and write the formula. So first let us try. We have penta-aqua-nitrato chromium 3, right? So I'll first write chromium, then I have penta-aqua. Okay, so first of all I have penta-aqua, so you can see here 6 is there, we can eliminate these two. Okay, these two options are eliminated. Next we have nitrato. Nitrato means your NO3. Okay, now if I calculate, chromium charge is here +3, okay, and nitrato charge is -1 and water is 0. So what is the charge of this complex? This is +2. Okay, and then we have nitrate, that is NO3 -1. So what will happen? This crisscross we will do. So I'll get CrH2O whole 5 NO3. Okay, then we have NO3 whole 2. Okay, so this one will give me option number C, that is the correct answer. Okay, here you can also see this is not nitrato, so you can eliminate this option also very easily. Question number 18 now, the IUPAC name of this given compound. So this is 2018 question, again super easy question provided you know all the basic rules of nomenclature. So first of all, I'll see we need tetraamine. So I have here tetraamine, here tetraamine, here also tetraamine, and here also tetraamine. Okay, we cannot differentiate anything here. So next we have chlorido, here also chlorido, 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 chlorido. Fine. Okay. Next I have nitrito. This is nitrito N, right? We need to mention because this is a ambidentate ligand. It can be either nitrito O or nitrito N. So we must specify that it is nitrito N. So here nitrito N is there. Okay, here there is no specification, so eliminate this option. Here also it is not there, we can eliminate this option. Here it is given dinitro, so that is also wrong. So here we have nitrito N, cobalt 3 chloride. Okay, so if you see the oxidation state, here it is X, here it is -1, here it is -1, here it is -1, that is 0, and this will give you +3 state. So correct answer will be option number A. Okay, next question. As per IUPAC norms, the name of the complex given here is, okay, again the same thing you need to do. First of all, this is what question was asked in 2016, again easy question, same thing, you should know the basic rules of nomenclature. Okay, so now if you see here, we have like first there should be what, there should be this chlorido group, right? We need first chlorido group. So first of all, here also here it is chloro, here it is chlorido, here also chloro. Okay, fine. Next we will see that it should be bis-ethane 1,2-diamine. So we have bis-ethane 1,2-diamine, bis-ethylene diamine is not correct. Here there is di, that is also not wrong. So all are wrong. Only this is the correct option. Chlorido bis-ethane 1,2-diamine, nitrito, your nitro O you can write, cobalt, then here charge will be +3 chloride. Okay, so correct answer will be option number A. Okay, fine. Next question about is CFSE splitting. Which of the following complex in an octahedral complex has the maximum number of unpaired electrons? So this was asked in 2023. This question is very easy if you know how to write the electronic configuration, and you should know about strong field ligand and weak field ligand, right? That all things concept should be there. Now first of all, D9 high spin, what will be the configuration? So I'll draw here. So we have, okay, here we have T2G and here we have EG, right? So 1, 2, 3, high spin means there will be no pairing, so 5, then 6, 7, 8 and 9. So what will I get here? For D9 configuration, it is T2G6 and EG3, right? What is the total number of unpaired electron? Total number of unpaired electron is 1, okay? Next I have D6 low spin. So if I have D6 means all the electrons are paired, right? Low spin means there will be pairing. So I have here D6, 1, 2, 3, 4, 5, 6. So number of unpaired configuration is T2G6 and number of unpaired electrons is 0. Then I have D4 low spin. So, okay, so if I want to do D4 low spin, so we'll have 1, 2, 3 and 4. So it is T2G4. Okay, and what is the number of unpaired electrons? 2. Next D7 high spin, so 1, 2, 3, 4, 5 and 6 and 7, right? 1, 2, 3, 4, 5, 6, 7. So the number of unpaired electrons here is, we'll have T2G5, EG2, and the number of unpaired electrons is 3. Okay. So now the question is asking, has the maximum number of unpaired electrons? So you can see last option. So correct answer will be option number D here. Okay, fine. Next question, crystal field splitting energy for COCl6 4- is 18,000. The crystal field splitting for COCl4 2- will be. So this question is easy if you know the formula. Otherwise, I say this is a moderate level question. Okay, so what is the formula here? Delta O is equal to 4/9 of delta T. Okay, so that you should remember. Sorry, 1 second. Delta T is equal to 4/9 of delta O. Okay, so now if I put, what is the value of delta O? 18,000 I need to put here, right? So I'll get 8,000, right? 4/9 of 18,000. Okay, so that will give me 8,000. So correct answer will be option number A here. Okay, fine. Next question. For the crystal field splitting in octahedral B complexes. So here question was asked in 2021. Okay, so this question is based very easy if you have learned the CFSE diagram properly. Okay, so octahedral splitting, what happens? We have like this, 3 is here and 2 is here. Okay, and this one, what happens? This is minus 2 by 5 delta O, and this is plus 3 by 5 delta O. Okay, so what will I get? The energy of, so, and this is your T2G and this is EG. Okay, so T2G energy decreases by 2 by 5 delta O, right? So energy of, the energy of EG orbital will decrease? No, because energy of EG orbital is increasing. So this is wrong statement. Energy of EG orbital will increase, that is correct, by 3 by 5, that is also correct, and that of T2G will decrease by 2 by 5, that is also correct. So this is the correct statement. Energy of EG orbital will increase by 3 by 5 and that of T2G will also increase. This is wrong because T2G is decreasing. Energy of EG orbital will decrease, that is also wrong. So correct answer is option number B here. Okay, fine. Next question. The correct order of wavelength of light absorbed in the complex ions are. Okay, so correct order of wavelength of light absorbed. Now see, this is very important question. Okay, and if you do not know this energy and wavelength radiation, then definitely you will make a mistake here. Now first of all, see, if it is a strong field ligand, okay, then splitting will be more. Okay, splitting will be more, energy will be more, but wavelength will be less, because you know this relation, E is equal to Hc by lambda. If energy is high, then wavelength should be minimum. Okay, now first of all we need to think in this 1, 2 and 3 where the splitting will be more, where there will be more number of strong field ligands. Okay, so now we know that the order of the ligands is Cn is strong, then we have NH3, okay, and very less will be Cl. Okay, this is the order of the what I can say ligand strength. Okay, so now let us first tell me the order of splitting. So splitting, so which one will split more? Because here all the 6 ligands are Cn, there will be more splitting here, right? 3 will split more. Okay, so I can write splitting order will be 3. Then here you have all the 6 as NH3, so this is 2, but here you see there is chlorine, like there are 5 NH3 and 1 chlorine. So compared to 2 and 1, 1 will have less splitting. So this is 3 to 1. Splitting will be in this way. The same will be the energy order. What will be the order of energy? Order of energy will be so here we require more energy, less energy, least energy. Then what is the order of wavelength? So wavelength will be opposite to this order, right? So we have here, see, this one will have least energy, means its wavelength will be maximum. So the order of wavelength will be 1, 2 and 3. That is why correct answer is option number A here. Okay, fine. Now let us see the next question. 1 second. Okay. So 24, according to crystal field theory, the Ml bond in a complex is, so 2017 question, very easy, but you should, many of you do not study the definitions and all, otherwise it is a easy question, that is, it is purely ionic. You might think that the chapter name is coordination compound, so it may be purely coordinate, but you should remember, according to crystal field theory, it says that the metal ligand bonds are purely ionic in nature. Okay, fine. Next question. Which of the following sequence is correct regarding the field strength as per the spectrochemical series? So 2016 question, spectrochemical series order, if you have remembered, then definitely this is a very easy question. So CO is the strongest ligand, then we have Cn, okay, then we have F minus, and least is the SCN minus. So correct answer is option number A here. Okay, fine. Next question, the complex ion having the minimum magnitude of delta O. Okay, again this question is asked in 2015. This is also a very similar question. You should know about the delta O. So as I told you, splitting splitting is depending on the strength of ligands, depends on strength of ligands, right? So now if you see what all ligands we have and I want to order them, then chlorine will be the least one, okay, then we have water, then we have ammonia, and highest is your CN, okay. So there will be minimum splitting where there is chlorine, because chlorine is a weak field ligand, so minimum splitting will be there. So correct answer for this question will be option number D. Next question, a correct statement is, so 2014 question, so it has like combination of many concepts have been involved here. So CONH3 whole 6 2 plus is paramagnetic. So if you have seen the CONH3 whole 6 2 plus, okay, so its hybridization is D2sp3, okay. D2sp3 hybridization, because it is having D2sp3 hybridization, there is no unpaired electron, NH3 is a strong field ligand and it is a paramagnetic component. So correct, this statement is correct, okay. Next, sorry, it has no unpaired electron, one second, no unpaired electron, okay, so it is diamagnetic, so this statement is incorrect, okay, I am very sorry. Next, if you see MnBrO4 2 minus is tetrahedral. So if I see what is the structure here for manganese, MnBrF4, right? Okay, so Br also is a weak field ligand. Here hybridization is sp3, because sp3 is hybridization, it will be tetrahedral, right? So this is a correct statement. Next one, if you see COBr2En whole 2 exhibits linkage isomerism. Now for linkage isomerism there need to be a presence of ambidentate ligand, right? Because there is no ambidentate ligand, this statement is wrong. Now NiNH3 whole 6 2 plus is an inner orbital complex, this is also wrong. Here also the hybridization is sp3d2. So sp3d2 means outer orbital is used, so this is a outer orbital complex. Okay, so correct answer for this question will be option number B. Means the correct statement is option number B. Okay. Next question, we'll go for organometallic complex, that is chemistry. Which of the following is an organometallic compound? So 23 question, very simple question if you know the definition. So there should be a bond between a metal and a carbon of organic compounds, okay. So that you can see in CH3 CH2 MgBr, okay, this is carbon, this is metal, bond is direct, so option number B is the correct answer here, okay. So here there is a bond between oxygen, here also there is bond of oxygen, here also there is bond of oxygen, that is why these all are incorrect options. Next question number 29, CO is a stronger ligand than Cl minus. So CO can form pi bonds, right? You know that synergic effect concept, right? That is why it is a very strong field ligand. So correct answer will be option number B here. Okay, this is important question, okay. I'll say it is almost like difficult type question asked in 2024, okay. On treating 100 ml of 0.1 m aqueous solution of complex CrCl3.6H2O with excess of AgNO3, 2.86 gram of AgCl was obtained. The complex is, okay. Now first of all we should know that how many moles of this particular complex is there for us, okay. This was asked in 24, a difficult question. So first of all if you see, we have molarity is equal to number of moles into 1000, okay, by volume. So now if you see, calculate number of moles will be how much here, we have 0.1 divided by 1000 by 100, so that is 0.01, okay. This many number of moles I have, okay. Now if you see, this is treated with excess of AgNO3, okay. So this compound complex formula we don't know, we have CrCl3.6H2O, how many moles are there? 0.01 moles are there. Now what will happen, if you see AgCl molar mass is 143, okay. So that means this is given mass, this is molar mass, so number of moles of AgCl will be how much? Given mass is 2.86 and this is 143. So I will get 0.02, right? So that means 0.02 moles of AgCl is being formed, right? So that means 2 chlorine must be outside. From 0.01 moles of this one, we are getting 0.02 moles of AgCl. That means 2 chlorine should be outside. So what will be the formula here? CrCl H2O whole 6 Cl2, right? We need 2 chlorine outside. Okay, so water can be inside or outside. So here you see there is no chlorine outside, here 1 chlorine, here 2 chlorine, here also no chlorine outside. So correct answer will be option number C. Okay, here there cannot be, it has to be 5 because we need coordination number cannot be more than 6 here. Okay, so that will be the correct answer, option number C. Next question, the complex compounds, these two are given to you, are which type of isomers? Okay, 24 questions again on isomers. So if you see, if you dip this in water, dissolve this in water, we'll get different ions, and you dissolve this in water, will get different ions, right? So that is your called as ionization isomers, option number D. Okay. Next question, which of the following statements are true about COF6 3- ion? So 2024 question, against a mixture of concepts are here, you should be knowing about the VVT. The complex has octahedral geometry. Whenever coordination number is 6, the complex will have octahedral geometry. So this is a correct statement. Coordination number of cobalt is 3 and oxidation state is +6. No. Coordination number is 6, cobalt oxidation state is +3, so this statement is incorrect. sp3d2 hybridization, yes, this is a weak field ligand, so it will have sp3d2 hybridization, and it is a high spin complex. Okay, so if you see here, so we have statements like 1, 3 and 4 are correct. So that is your option number C. I'll show you how the hybridization is coming sp3d2. Okay, cobalt electronic configuration is 3d 7 4s2, right? In +3 state, right? What's the oxidation state of cobalt here? +3. So if it is +3, we will get 3d6. Okay, so we will have like this 1 2 3 4 5 and 6. Okay, so I have 3d, then 4s, and then I have 4p. Now what will happen? Because it is a weak field ligand, there will be no pairing. So hybridization will be from 4s, 4p and 4d, sp3 and we have d2. Okay, so hybridization will be sp3 d2. Okay, so that is why it is a high spin complex, because there is no pairing and it is sp3 hybridized. So correct statements are 1, 3 and 4. Okay, so yes students, these were the top 30 PYQs from coordination compounds chapter. You can practice similar questions and can expect similar questions in your KCET 2025 examination. Okay, so I hope this session was helpful for you and you could have known like what is the level of questions from this particular chapter. Okay, so remember, just your target, we need to hit 60 out of 60. So thank you for watching, and if you find this series helpful, this video helpful, then do not forget to subscribe the channel. Okay, thank you and see you soon in the next class.